we can. Okay, there are some questions regarding the Vishwa. I think the Vijayanagaram people seems to have been able to execute the Vishwa on some nodes, I think, right? Did in executing it on few nodes, the Vishwa code. Okay. How many nodes were you able to execute it on? Somebody else was saying that he has a problem. Yeah, yes. All of them are Linux nodes or Windows plus Linux? Linux only. Okay. So I think the Windows nodes also it works. If somebody is trying it out on Windows nodes also, it should work correctly. Somebody else was saying he has a problem while which college was that? What is the problem that they're saying they had? L3. Insufficient nodes error means that you have not added sufficient number of nodes. Actually, you should. We tried with one Windows and one Linux and could not succeed. You need more nodes, obviously, right? So the code will say that it will require unless you put it on one single node. The number of maximum donor, minimum donor. If you try changing it to 1 and 1, maybe it will succeed. But then what is normally suggested is at least you should create 3 nodes. Okay, 3 nodes with Windows. You should have one extra journal server, and you should have one more node from which you should submit the task. Okay. Were you able to do that, or are you not able to do it? Got exception saying that J Vishwa subtask class definition not found. A class path problem, I think. See, it should never be J Vishwa, That's a class path problem, clearly, Okay. See, I can show you how to actually run it on multiple nodes. That's not a problem. But then I think Vijayanagaram campus seems to have succeeded. Okay, that's one group that seems it's fairly simple. All the 7 steps are quite well written, and then it should not take any time for you to actually go ahead and execute that code. We'll take that as one of the assignments for the people because it's simple, and then they should be able to do this. Okay, as part of the course, we will use that as one of the assignments. Okay. Somebody was asking me for the for creating this thing in the cloud. I think I've created that in the cloud and then shared that address. Okay, but there are a couple of issues running this on the cloud. Yes, the journal server did not respond. That is correct. Actually, I think there seems to be some issue running this in the. I've left the journal server on. So, but then it looks to me that there is an issue which I should resolve as far as the cloud version of this is concerned. No. I'll do one thing now. Actually, I'm starting the journal server on the server. So just check if you are able to. Oh yeah. Okay. So this is. In fact, you can start multiple journal servers. So I think yeah, this is on now. I've just started it in the you can see the running part of this software here. Let me just share the desktop. Start desktop sharing. Okay. Now you can see it here. If I give 1, this will give the number of rows and all that stuff. If any of you actually try adding yourself in here, it will get added. You do the following actually. Any of the colleges have an IP address which is an external IP address. You can't have 10 dot address because with 10 dot address you should not be able to, though you will be able to connect, this will recognize that as a 10 dot address. So working back to your node will be a problem. Okay. Does Vijayanagaram College has an external IP address, addressable IP address? Then they should be able to connect to this zonal server. Okay, the zonal server IP is no 52.23.218.223. Okay, this is what it will be. Okay, 52.23.218.23. Okay, right. Now what you have to do is you have to just, for example, you can connect up to this server by opening the other one. Okay, now you can yeah, this is what you can do. For example, yeah, if I just do this J Vishwa and give the journal server, it should get connected. Okay, um, but it's taking a very long time for it to actually get added, connected, because of the, this is one of the things that I want you to understand. Now you can see, since I moved it to the cloud, you can see the response times is sufficiently slow now. In fact, it tells that it takes quite some time for this to actually connect up with the journal server which is outside. Okay. So this is something that you start seeing. There is a chance for further research on this direction. So if you want to cloud seed, the journal server, and attach the outside nodes into this journal server and use it as a voluntary cloud formation. Okay, you can cloud seed this journal server in the cloud and have other nodes connecting up to this journal server on which you can start programming. Then you need to probably redesign this software a little bit, because it's the first time we are experimenting this. We did experiment with this software by connecting up nodes from Australia, nodes from EPFL, and then but then the IP address is there, and then we have control on the see, now it's actually says the operation is timed out, which means that I'm not being able to connect up to this journal server. So I see that there are issues with connecting up to the outside cloud server. Okay, but this may actually, if you have a DigitalOcean no system, we can do an experiment here. We can create a droplet in the DigitalOcean, okay, and try connecting to this journal server and see, does it still time out? Because the timeout means that it waited for a sufficiently long time, and then it is actually timing out and coming out of that connections. Okay, but once in a while it's actually connecting, but then it's saying that it's taking enormous time. I think 7 to 8 seconds is what it is showing, the connecting from the local node to the cloud node. Okay, this in fact tells you the problems in terms of architecting to the cloud. How this is one of the interesting things. When you move applications to the cloud, you need to worry about the service being accessible over the network, which will result in QoS problems, which will result in in other kinds of issues that will be part of the cloud infrastructure. The additional thing that you need to worry about, now you can see, this really looks like slow for me. Okay, is anybody else able to do this? Vijayanagaram College is able to connect up to this. I'm able to connect it up once in a while. I'm able to connect it up, and then it's no, it's sort of coming up, but then it's only connecting at some points of time, but with a lot of latency, not that easily connecting to the cloud. Okay, 80% of the time it is actually timing out, and a few times it's able to just connect it up to the cloud seed. Okay, and also you should realize that I'm actually running this from a 10.6 address. I'm not running it from a 203 address. So if I'm actually running it on a 203 address and trying to connect it up, it should be fairly faster. Okay, I should be able to get onto the internet faster I'm using a slow speed connection to the internet. So that's also the result that this will actually time out. We'll come back. Okay. Uh, I think we can continue this experiment. This is a good thing to research on and see if we can create voluntary clouds using the cloud seed in the putting the journal server, which is a cloud seed, in the cloud. Okay, in terms of research, this is worth experimenting. In fact, one other thing that you can do is this, again, you can experiment it yourself. Okay, the journal server, you can create a local journal server, and you can okay. Um, See, in fact, I can create this additional journal server, which is not the first journal server, okay, and then can create it at a local node. For example, I can go to this uh, local node and then create an additional journal server. I think I have the this thing here. Journal server is there, so I should be able to start the journal server here. So let's start journal chart. Okay. Journal server ID will put as 2. It is not the first journal server. I think we have to actually give the both have to be 00 here, because now this you can give this address and then can connect up very easily. Now you can see this becomes very fast, because now if you say you go to Vishwa and you say now Java minus jar, okay, and give the Vishwa jar, okay, and give this 10.6.9.81. This is what you are expected to do. Okay. Yeah, this is what you will get. For example, you can look at it. It took 10-21 milliseconds to actually connect up. Okay. Now this is still in the cloud, right? So I'm actually started that up, but then I think you can see here J Vishwa. This is the thing that's now if you reply sent, all this is a message that you will get here. So if you give 1 here, it will show that 192.168.06 has been added here. Okay. In fact, I have multiple machines, then I can just add it up into this, and then I can fire the uh, program for you. And in case you're not able to do this, I will show you how to do this in the next class. But then what I'm trying to suggest is it's possible for you to create one journal server locally, one journal server in the cloud, another journal server in another place, and connect up all these journal servers. Okay. Then no, then you can actually will be able to connect up multiple multiple private virtual clouds to the bigger voluntary cloud, which is seeded in the actual outside cloud. So you can have these multiple local clouds which are created, which can be used and which can be connected to the cloud seed. So it's possible to get multiple things, multiple ways in which this can be done. This is something that is worth actually, since this software now if people are having, you can actually experiment with this. Quite a few colleges actually use this software. In fact, they do a lot of other work in this. I remember we actually did give this software, and then my students conducted a workshop, if I remember right, in Goodlavalleri College, because one of their students was here as an MTech student. He wanted to go back and then work with this college. So I remember this was done for that college and few other colleges, including the Pondicherry University, and now some universities abroad, Pune University, Bharat University, and Shastra University. Quite a few universities have this as a syllabus, and they actually use this software as part of their curriculum to teach students how to actually program, do parallel programming on clusters. Okay, so it's what for you. If you go into the tutorials, it tells you how to write programs that can run on these multiple nodes. Okay, right? So I think you know you can look it up yourself. You can do the work on this, and then if you need any support, you can suddenly come back to us. One part is if you look at the way you program on Vishwa, the difference between Vishwa and Hadoop is Hadoop first comes with a file system called the Hadoop file system. You're putting the Hadoop file system, and on top of it, HDFS is what you're programming. On top of it is what you are actually doing the programming on top of the HDFS. Okay, the MapReduce is working on top of the HDFS. Whereas in the case of Vishwa, you send the entire task to the other node and the data also to the other node and get the results back. So that's how you work in Vishwa. Okay, the current technology, if you look at the current technology called the Docker technology, which is trying to replace most of the other things. Okay, Docker is one of the most popular technologies that is getting developed. Docker works very similar to Vishwa. Okay, Dockers are containers which will run on top of the operating system, and you can ship these Dockers to run anywhere in your distributed system. Like what's happening in the case of Vishwa, where when you are actually connecting up all these machines together, and when this JVishwa is running on all the nodes, what in effect we are doing is you are sending the program that needs to execute on the distributed system along with the data to whatever nodes that are connected up now, and choosing those nodes and executing your program on it and getting the results back from those nodes. Okay, so from that sense, this is much similar to what is coming up as a Docker service. So one of the projects that we are attempting now with a US company is to turn this Vishwa into some kind of a Docker service and see if Vishwa can be provided as a Docker service on the cloud platforms. Okay? That's, I think, one of the major projects that we are attempting to do now. Okay, Balaji, you're supposed to have taken this lecture today, right? No, are you ready? Yeah. What happened? You're supposed to be here at 2 o'clock. Yeah. No, yeah. Okay. I think you should continue from where you left so that I can continue once you've shown them the installation. Okay. Yeah. Okay. Yeah. So I think no. Yeah. So that's, I think, one of the major projects we are into. One of the also ideas of giving this to the colleges is when we are working with them to make them familiar with this. Now there is a chance for them to do a lot more experimentation with this and do some more student projects around this. Okay, suddenly I remember students trying to use on 100 nodes, 100 Windows nodes, and executing large programs, doing performance benchmarking, and then trying to publish the results as part of papers and all that stuff. Okay, so there is a chance for you people to be doing research on top of this and doing good student projects. In fact, that's one of the key things I'm always been emphasizing. The teachers, especially, what they should do is when they're working with the BTech students, they should give projects which will feed into their research. For example, if who is doing some sort of a small project, should lead to another project by another student. If you look at, for example, Vishwa has been developed over a period of time of 10 years. Okay? There are multiple PhD students, multiple MS scholars who work with me, and we each one incrementing step by step to get to this stage of having a software that's now being used by a large number of people. In fact, I do a lot of experimentation using this. Okay, and I modify this. I continuously keep updating this kind of stuff. So building things over a period of time is what you should attempt to do, and this will also give interesting projects for the students. For example, I know a German was talking to me in giving this Vishwa as a project and trying to extend. He wanted the source code because he wanted to use this and extend it further. So we were actually working with him to support him to actually extend this particular thing. Okay? So multiple projects are possible, multiple research projects are suddenly conceivable. For example, one of the key things now we can think of, along with a couple of other faculty and colleges, is how do we extend this to the cloud seed experiment? How do we do a cloud seed experiment using Vishwa? you know if you are able to do that, for example, some of these ideas can be experimented. The first experiment that I want the Vijayanagaram campus to do, they have also been forefront, they are able to implement this already. One of the experiment that I want them to do is start a journal server locally and create another journal server in the cloud. See if this actually create two local clouds and put the seed in the actual outside cloud and see if you're able to connect it up. The other experiment that you can do is put one in EC, Amazon cloud, and one in one grid node. One journal server can be in Amazon cloud. One grid node can be in DigitalOcean. Another one can be in Rackspace, and see what kind of performance issues will come when you are doing across clouds. This is becoming very important now. What's becoming very important is now there are multiple clouds available. There are hybrid clouds. Now there are multiple clouds. So how do you program on multiple clouds? Okay. For example, one of the major research themes that we have pursued is if we have a set of local nodes, 10 local nodes, and there are 10 nodes in the Amazon cloud, how do we program on top of both these clouds? Okay. How do we implement MapReduce on hybrid clouds? There's an internal cloud and there is an external cloud. How do I now program on this kind of hybrid clouds? That becomes extremely interesting, because if you do a MapReduce programming on the local cloud, this is going to be suddenly faster. But if you want to fire a MapReduce job across multiple clouds, okay, one cloud being the external cloud, one cloud being the internal cloud, the link connecting up these clouds becomes the bottleneck. That becomes the issue. Like what's happening now, the outside connecting to the outside journal server is suddenly a bottleneck, when you can see that you are able to connect up very easily to your own local area network. Connecting to an outside cloud located in Singapore or US is going to be much more latency prone, and then you might actually even time out, resulting in the cloud being disconnected, right? So those kind of issues will come when you are programming on the internal cloud and the external cloud. One of the architectures recently we have developed for programming on an internal cloud and external cloud hybrid clouds is do a MapReduce in the internal cloud, do a stream processing in the external cloud, which means that a stream of data will be sent to outside clouds, uh, and then we actually do a stream processing in the external cloud, not the batch processing. So certain sets of data is actually streamed out to the external cloud, get the results back in time, and then start putting it into the local cloud, which is doing the batch processing. Okay, I'll show this research. This research is published in 2014 in the IEEE Transactions on Cloud Computing, called the B stream. This is interesting work from the perspective of how do we work with an internal cloud and external cloud. Okay, uh, in general, this is a scenario that you are going to see in the cloud computing. You are never going to work fully with an external cloud. You are not going to work with an internal cloud, okay, fully. You are going to work with a hybrid cloud, which means that a part of the resources are going to be in the internal cloud, a part of the resources are going to be in the external cloud. That's how you're going to program with the cloud. Okay, internal cloud plus the external cloud. Now, one of the important research directions that is being pursued by several groups is, if that is a scenario, how do we support Hadoop MapReduce kind of jobs on these hybrids? Okay, I'll show you these as we go further. Maybe if time permits, we're going to see this work and see how it becomes very interesting to work with hybrid clouds. I guess these guys should be ready now. Let me see if they're ready. Are you guys ready? It's coming then. I'm just giving it to both Balaji and no, Balaji and no, Abhinay. They're going to take you to the last step. Whatever they have done, they're going to continue with that. I think it's almost 2:40 now. It's supposed to be 2 o'clock. What happened? I got. You didn't know. Okay. Few steps are remaining. Yeah. Stop and
Good afternoon, everyone. In the last class, we have seen how to set up the SSH connection between master node to the slave nodes. So I think we have finished up to this copying the public key of master to the slaves. So once you have done that, you can check whether you are able to SSH through the slave using this command SSH. You can give the hostname or IP address, whatever it may be. So once you have done that, uh, I will show by logging into my machine where currently we have installed the boss mule along with that Hadoop stack. Yeah. Now I logged in there where we set up this boss mule along with Hadoop stack. So now I will uh, start the daemons. So I think it's already started over there. That's why it is showing name node running as a process already. Stop it first. So just use JPS. You can see uh, the nodes, data node, process name node, node manager, resource manager. These are the process running at the name node side. And we have configured one machine as a slave. That is, I will log in there. PT. right? IT 84. Letters are too small. Give me 1 second, I will increase the font is small. Mm, what are these? Mm, 53, mm, yeah, mm, after this, we have already configured the XML files where we have to where we want to set the location for the Hadoop blocks. So these are two XML files. You can see that in etc folder. So one is course site.xml. So here we are setting the port number for the name node, and another one is yeah, HDFS location in your local file system. Yeah, we store the we have given the local file system location as you can see here. So you can observe this folder will be created once by default. I think it will already created because we have already checked here. So there is no need of formatting, I think, for you. So these are already preloaded configurations we have made, and once you have verified whether this folder is present or not in your local file system, that HDFS folder, whatever you have given the location, then you can start these daemons. So and I forget to say one thing. So here one more file is there, that is where you can mention slave locations, like which nodes you want to act as a slave, and so these are the two files you have to name. So here in my case, the master node along with it will act as a data node also. So that's why I give master also here. And this is the master file. Master location is where the secondary name node will run. So and once you start the once you give the command start all.sh, so what it will do is it will start the name node process wherever you have given that command. So just I will show by logging into my master node. Oh, is there any questions? Okay, I'm moving on. This JPS is a Java utility where you can check the daemons are which daemons are currently running in your machine. So now I am giving that command in my master to start the daemons. So it will start the daemons at my master node as well as data nodes also. So this is Yeah, you can see the if you have any problem in starting the daemons, you can see the log file is generated at a Hadoop logs location. You can verify whether it has successfully started or not. If the exit status is 0, that then the daemons get started properly. Otherwise, you can check the errors over there for the errors. Sometimes you may see that the data node daemon is not getting initiated because if you format the name node, then the cluster IDs between the name node and data node may change. So sometimes there may be a case that data node may not get initiated. So make sure that the daemons are running. Yeah, in my master, these are the daemons. You can see name node, data node, node manager, manager, and now I am logging into slave mission. Is there any questions? You can see the data node and node manager process are running here. So now you set up the Hadoop environment. Next step is you can give the input and uh, you can run map reduce job on top of that. So now I will show how to give the input. So you can give the commands like dfs, and the command argument should be just like making directory, just like a normal local file system. There is utilities like mkdir, cat, ls. All those commands will work, but you have to give bin hadoop dfs prior to that. Yeah, this is the you can see this is the input file I have given. So then now you can give the job. I'm just running a word count example on that input file. Just give the class name and your input file location, and then the output. You can see that job is currently running. Once it completed, it will generate uh, with the file name whatever I have given in your HDFS file system. So in fact, you can check with web interface also. You can just give the master IP address followed by the port number, that is 50070 in this case. So you can check what are the data nodes are running, and you can even check the file system also, HDFS file system also. So our now I done with the job. you can see the output is the generated output over there. So is there any questions? So, do you started installing? Do you downloaded that Mool Hadoop stack? Okay, I will show the output. So basically, the output is a directory. There you can it will you can see that in the web interface also. Based on that, give the file name over here. So one file will show you whether that job is successful or not, and another file will consist of that output, whatever you want. Distributed. Okay.
So hi there. So we showed you the basic installation and uh, how to run MapReduce job on Hadoop after configuring. So we just followed the manual which we have put it in the VDI image. So anybody has any doubt on any of the steps in the manual, you can ask right now on the chat. Okay, and so right now we have a question about the configuration files. So I think Balaji will answer that question. So if you have any other doubts, you can ask on the chat.
Here you are mentioning the job tracker location. So here in my case, the master where I would like to run my secondary name node, followed by the port number you can give. So it will start uh, job tracker at this machine, this port number. More
Yeah, installed now. You can run and continue on Friday. Sure, कुछ नहीं करना होता है
Example, you are running executing MapReduce using HDFS. Yeah, it is not locally. I set up that pseudo distributed mode. So in that I am running the job. It is not local HDFS.
correct है ना, locally नहीं है, directly installed in two machine.
So basically I set up the pseudo distributed environment mode where one master node is there and one data node. So any other questions?
Flexibility is not local.
No, currently installation process I am saying. So please explain so by next week you have to set up these Hadoop install this mole on top of mole Hadoop stack. So by next week I think you will have some assignments on that. So please make sure that by next week you are able to install it. Hmm. Is there any questions on installation? Okay. So please make sure that this week you are able to install it.
Suzuki have we all try to install it. Suzuki
Yeah, I think, yeah. So what we will do is we will make sure that they are,
Someone are experimenting with Vishwa.
yeah, they can experiment with Vishwa also. Now the question is, no, we'll stop desktop sharing now. Okay. Yeah, just pull that chair. I think we will plan, keep it on top and then pull that chair. Okay. Yeah. Okay. I think what I suggest is, um, have you all been able to download this Boss Mole VDI along with Hadoop, where everything has been configured, pre-configured and set, and we also gave an installation guide, which will help you to actually take the whole process easier. if you
Network technology.
let me finish my class and then we'll check.
No, it does not use it.
No, not now. Yeah. So yeah. So is that clear now? Are you able to download that VDI file, or you have any difficulty? Oh no, you have not installed that. This is actually, no, please understand, this is actually only a VDI file. So once you install get the VDI file, you can start it off in your virtual machine, virtual box. So it's much simpler here. That's why we're giving everything pre-loaded as components we're giving for you, so that you can get started and you can start experimenting, because otherwise it will be a challenge to actually download the Hadoop and then start up on your own on the cluster. That will take you some time for you to be able to set up a Hadoop cluster. That's where we're giving you this VDI file, and making sure that okay, right? Did you explain him this, the anatomy of the MapReduce? Okay. See, somebody is asking the pseudo distribution versus yeah. So this you do that. Pseudo distribution versus distributed cluster. Pseudo distribution is it will run on a single node. Okay. Yeah, please do this. Some question is there regarding pseudo distribution versus the actual distribution. So if you the pseudo distribution will run on a single node. It's actually just a single node instance of the Hadoop. You should not do that. Actually, you should start up on multiple nodes and you should work on multiple nodes. Okay, right? As part of this course, you should at least set it up on 3 data nodes and one name node as part of this cluster, and experiment with at least we expect that you should be able to do word count um, program, MapReduce word count program. Have you shown them the word count program? Yeah, okay. So at least you should be able to, by the next class, if you download it and start executing this, then they can clear further doubts on Friday between 2 and 3. First thing is you should all be able to install it, do the word count program, MapReduce program, how to write the word count MapReduce program. Once you have done that, we are going to give you one exercise on finding out co-occurring words. We have to modify this and run for the co-occurring words, the program for co-occurring words. You have to rewrite parts of the maps and reduce for finding out the co-occurring words. Okay, that's the exercise that you have to do. So we have to take you to these steps. Okay, now that's all what we want to do. A little bit more information on how the MapReduce programs run and all that I will give you. But then I think next few classes we are going to first make you set up this Hadoop cluster, make you do the word count example, and make you do a couple of exercises on this. Okay, right. You can also meanwhile start working with Vishwa. I'm also going to teach you how it works. In fact, you start finding out Vishwa is much simpler. That's what everybody tells me. Installing, setting up the clusters using Vishwa is much simpler than setting up the Hadoop cluster. So that way you will also see the difference between these two and how you can work with both of this. Okay, right? Okay. Are there any other questions? Yes, you have to download this by next week, set it up. They will go through one more time with the steps for setting it up. As you got them, they'll also have one more session on. Go through these steps once again, see if you have any doubt. Only when you download, install it, then you get the real doubts. Otherwise, you won't get the doubts. Okay. So you have to get this, run the MapReduce program for word count, and you have to extend that for the co-occurring words. That's the exercise that you will be doing. Okay, so you have to do this by next session. Have you got the link where the stack is there, Bosmol stack that we have shared? Have all of you got that? The VDI file is slightly larger. So what I see, Vishwa is very simple. I think Vishwa has already been installed by people. Okay. Yeah, these I think are not possible as we have already told. Okay, right? Yeah. So both Vishwa and the Bosmol stack have to be installed by next class. Okay. Then you have to actually run the word count example. On Vishwa, you have to run the prime number client. I think Vijayanagaram College has already done that. So the other colleges have to do both these exercises. I think the Bosmol also has been installed by the Vijayanagaram College. The other colleges have to install this. Okay. Once you have done this and you have done the word count example, then we are going to give you the co-occurring word example, and we'll teach you a little more on the how to do these programs, okay, as you are executing. Okay. Next class, Balaji and